Lesson 13.1, Scatter Plots and Fitted Exponential Curves. All right, as we go through this, I'm going to show you how to do different things using your TI-84, and you should take time to pause video and make sure you can do these on your own with your own device. That way, when you're working on problems alone, you will know how to do certain things. All right. Santiago measures the temperature of hot water over time and records his data as the difference in the measured temperature and the room temperature as shown. After 5 minutes, he puts an ice cube in the water and then continues to measure the temperatures. Make a scatter plot of the data. Use your scatter plot from Part A to explain why the situation should be modeled using a piecewise defined function. Use regression to determine the functions that make up the piecewise defined function, and use the model from Part C to predict the temperature difference after 20 minutes, and then decide if your answer is reasonable. All right, so the first thing it says is make a scatter plot. So we can use our calculator to make a scatter plot. All we have to do is enter the numbers in our table. So go to Stat. Well, I have to turn it on, but turn it on and then go to Stat and hit Edit, and then I'm going to enter these numbers. So you can hit, I'm going to hit pause for a minute and enter this, and then I'll be back. So take as long as you need to enter your data. All right, once you have your data entered, always make sure that the points that you put in are the same as the table, because if you enter something incorrectly, it cannot give you the correct model or the correct equation if it has the wrong set of points. All right, so now we have the table put into our calculator, and the first thing it said was to make a scatter plot. So to make a scatter plot, I'm going to go to second Y, it says stat plot here, and I'm going to hit enter. So I want to turn this on. That way it will give me the dots. You can see here the type, it's got the dots here, so that's going to give me a scattered plot, and it's going to pull from my list 1 and list 2. So I'm going to enter through this and then hit graph. Now what you may notice is, again, my table is set, or my window is set at 10 by 10, and I go from 0 to 10 on my X or my T-axis, but not on my other axis. So there's no points going to show up because the smallest Y value is a 27. So you can see that this is going to be exponential decay because it's getting smaller as it goes down through there. But what does that mean for our window? So on a T, we're going to have from -1. We always have to have a negative in the calculator here. So I'm going to go from -1 to 10. I'm going to use a scale of 1, that's fine. And my Y's, I'm going to do -1. And I go to 145 here, so I'm going to go at least to 150. So if I go to 150 and then I hit enter, I can use a scale of 10 here would be fine. That would include all of my data. And then I'm going to hit graph. Now when I hit graph, I'm going to see my points. They're going to show up. Okay, so if you remember when I read, it said this is representing hot water, and after 5 minutes you entered an ice cube, so then the ice cube would cool it off much quicker. So you can see that these are two very distinct sets of points here, even though it comes from one table, because there was a change midway that's going to represent two different sets of data. All right, so it says after 5 minutes, he put an ice cube in the water and it continues to measure the temperature. Make a scatter plot. We did that. Use your scatter plot from Part A to explain why this situation should be modeled using a piecewise defined function. All right, again, because after a certain point, after 5 minutes, the ice cube was entered, and that means that it changes at a much quicker rate. So it immediately would have a drop in temperature just based on having ice cube entered in hot water. Okay, so we're going to make two functions, one for 0 through 5 and another function from 6 to 10, and that will be our piecewise function. Okay, so let's go ahead and do that. So I'm going to go back to my table, and if I go to edit, the first time I'm going to go down to just row 6, and I'm going to clear these out. Let's see, delete. Alright, it's not going to let me do that, so I'm going to go second plus clear out my whole table and just start over. Alright, so now when I go back to stat, I'm going to do edit, and this time I'm just going to enter the first part of the table. So I'm going to enter up through 5 minutes, and then I'm going to write an equation based on just this half of the data, which you can do that. You can choose if you want to split the data. Alright. Make sure these numbers match: 45, 37, 32, 26, 12, 02, 0, 1, 2, 3, 4, 5. Okay, when I know that my data is correct, I'm going to go back to stat. And actually, if you want to hit graph again, you're going to see now it's just this top part. But now I want to write an equation for this. I'm going to go stat. I'm going to go calculate, and it's going to be exponential regression. It's going to be actually exponential decay, even though it is exponential regression. We know it's going to be decay because the numbers are getting smaller. The y values are going from 145 to 102. So you can see my b is 1 minus my interest rate, and that would be 0.93 because this number is between 0 and 1. That shows me that it is exponential decay. So let's write a function for the first one. So we're going to have y equals 148. So y equals 148. And just to kind of round that, I guess we'll do 148 and then 0.93 for b. And this would be my x value. And again, if you want to use t and f of t, then that's fine. All you have to do is switch this out. So my x value would be my t, and this would be f of t. All right, now I want to do the same thing for my second function. All right, so I'm going to go back to my calculator, and I'm going to do second plus 4, which clears out my list again. Second 4 plus, and then go stat, edit, and this time I'm going to start with 6 and go through 10 because I'm going to do just the second part of my table. And I'm going to do 70, 61, 51, 36, and 27. All right, make sure those are correct. I'm going to go back to stat. I'm going to go to calculate, and I'm going to do exponential regression again. And this will give me my second part of my function, exponential regression. All right, and this time it's going to be 323.8. And my b value is 0.78. And again, if you want to use t and f of t. And then what does this piecewise function, what is it based on? So it's based on 0 to 5. So it's going to be t between 0 and 5. And this one's going to be t between 6 and 10. All right, so that's just our restriction on the domain. All right, so we know that the first part comes from before the ice cube was put in, and then the ice cube kind of sped it up a little bit, changed the function, and from 6 to 10 is the second part of the function. All right, so it says use your scatter plot to explain why this situation is a piecewise function. Use regression to determine the functions that make up the piecewise function. So this is the first function, this is the second function, and together this is our piecewise function by putting the two pieces together. All right, so it says use the model from part C to predict the temperature difference after 20 minutes. Is your answer reasonable? Okay, so after 20 minutes, we know that there was an ice cube in there. So what we're going to do is just simply take our calculator and use this equation. I'm going to hit clear, and I'm going to use 323.8 times 0.78 raised 2, and we want to do after 20 minutes. So time in minutes, here's time in minutes. So after 20 minutes, what is the answer? So that's going to be about 2.24. And it says, is that a reasonable answer? Well, that's about 2.5 degrees Fahrenheit above room temperature. So yes, that is a reasonable answer because it makes sense that the temperature will be close to, but still maybe a little bit above room temperature after 20 minutes. So this is a good model, and that's how you would use your calculator to evaluate these types of questions. If you have any questions, please let me know.